Overview of Control Survey. Hi there. In our survey, in order to limit the spread of survey errors and meet the needs of mapping or construction, we must follow the principle of reach out right hand. First overall, then parts. First control, then details. That is, control survey should be carried out first in this survey area before mapping and setting out. Today, let's learn about reach out right hand control survey. First, I will introduce a few concepts. Control survey. Control survey refers to the precise measurement of the spatial position of each control point using precise instruments and various methods. Control point. Select some points within the survey area that have a controlling effect on the overall. Control network. A certain geometry composed of control points. The basic task of survey work is to determine the spatial position of ground points. It includes determining the projected position of ground points on the plane, as well as the vertical distance from ground points to the geoid, i.e. the elevation of ground points. Therefore, control survey includes plane control survey and elevation control survey. Plane control survey, determining the planar positions of control points, i.e. the coordinates of control points. Elevation control survey, determining the elevations of control points. Next, let's learn about the National Plane Control Network. The National Basic Control Network, which is established nationwide, includes the Plane Control Network and the Elevation Control Network. It provides important basis for fundamental researches such as determining the shape and size of the Earth's gravity field, and earthquake monitoring. It also provides accurate basic data for space science and technology and military applications, and serves as the fundamental control for mapping on various scales and engineering construction throughout the country. The traditional methods for establishing a national plane control network include trigonometric survey and precise traverse survey. Trigonometric survey. Trigonometric survey is the process of selecting several control points on the ground, which form a series of triangles. The vertices of the triangles are called trigonometric points, observing the three internal angles of the triangles, and accurately measuring the lengths and azimuths of one or several sides, called baselines. Then, the coordinates of the unknown trigonometric points are calculated using a certain calculation method based on the coordinates of the known points. The triangles forming a mesh are called triangle mesh, while those forming a chain are called triangulation chain. The National Plane Control Network is divided into Class 1, Class 2, Class 3, and Class 4 according to the order of control and survey accuracy. It is arranged in an encrypted manner one class by one class from high to low level. Class 1 triangulation chain is the backbone of the National Plane Control Network. Class 2 triangle network is arranged within Class 1 triangulation chain to form a comprehensive foundation for the National Plane Control Network. Class 3 and 4 triangle networks further encrypt Class 2 triangle network. The main technical indicators of each class are shown in Table 6.1.1. Precise traverse survey. In areas with limited visibility or flat terrain, it is quite convenient to use the precise traverse survey instead of a trigonometric survey of corresponding classes. In particular, the emergence of modern electromagnetic wave distance meters and total stations has created convenient conditions for precise traverse survey. The traverse survey is to form a broken line with a series of ground points, observe the turning angles, measure the lengths of each side, and calculate the plane coordinates of each traverse point based on the initial coordinates and initial azimuth. Precise traverse survey is also divided into 4 classes: Class 1, Class 2, Class 3, and Class 4. 3. GPS survey. GPS survey is the process of placing a GPS receiver on control points to receive satellite signals from the Global Positioning System, and obtaining coordinates and elevations of the control points after processing. Next, let's learn about MapRU Plane Control Network. For small area engineering construction, due to the scarcity of national basic control points which cannot meet the survey needs, different methods should be applied to encrypt control points between advanced control points. Within the small area of 15 square kilometers, the control network established for large-scale mapping and engineering construction in a small area is called a Small Area Control Network. The Small Area Control Network should be connected to the National Control Network as much as possible, and the coordinates of the national control points should be used as the starting data and verification for the Small Area Control Network. If it is inconvenient to connect to the national control points within or near the survey area, an independent control network can be established as required. Small area plane control networks can be established according to the size of the survey area and the precision requirements. The highest precision control network established within the measurement area is called the first-level control network. The control network directly established for mapping is called the map route control network. The points that make up the control network are called map route control points, or simply map route points. If the aforementioned control points still cannot meet the mapping requirements, mapping control points can be established using the analytical method or graphical method, which are called survey station points. The density of mapping control points should be determined based on the mapping scales and the terrain complexity. Generally speaking, the density of control points in flat and open areas is slightly lower, while in difficult and mountainous areas, the number of control points can be appropriately increased. I hope that after this class, everyone can master the classification of control surveys, establish methods for plane survey, and complete the post-class knowledge extension tasks. That's all for this class. See you next time.